Welcome to our program, Astronomy for Everyone. Today's show is about one of the premier Star Party events held in Southeast Michigan, Astronomy at the Beach. And here to tell you all about it is John Schroer. John, welcome back to the show.
Nice to be here, Don. Good to see you.
Now, as I just mentioned, this is really the premier event. Can you tell our viewers about it?
Sure. The Astronomy at the Beach event has been held at Kensington Metro Park. This year is the 16th anniversary event. It actually started as an amateur astronomy get-together run by the Ford Amateur Astronomy Club that we both belong to across I-96 at the Island Lake State Recreation Area. And then 16 years ago, they decided to make it a public star party, and they moved to the larger Kensington Metro Park.
Yes, I remember when we made that move. Kensington is a much bigger facility, and on good nights we've had upwards of 5,000, 7,000, 8,000 people.
This is true. The event is sponsored by the Great Lake Association of Astronomy Clubs, and it's a organized group of the 6 astronomy clubs in the southeastern Michigan area. So we get to spread the workload a lot. Each year we have dozens of telescopes at Maple Beach. We have demonstrations by local universities. All the astronomy clubs have tables. And in fact, what we have for you is we're going to show you a little video clip that will show what it was like 2 years ago. You get to see some of the vendors, you get to see the clubs, some of the activities you get to participate in at Astronomy at the Beach.
Association of Astronomy Clubs work with many sponsors to host our 14th annual Astronomy at the Beach. This short video clip will focus primarily on the Ford Amateur Astronomy Club's beachside astronomers. This year's Astronomy at the Beach featured a number of tables from vendors, Wayne State University, and many astronomy clubs. The Mead table had quite a few telescopes on display. As we approached Maple Beach, we could see astronomers setting up their telescopes for evening viewing. Yellow balloons marked telescopes that could safely view the sun. Here's Doug Bauer, FAAC president, setting up his bead telescope. Nearby others were already viewing the sun through their personal solar telescopes.
Oh, it's on too well, okay.
Here, let me loosen it.
So you got a PST and a Vixen mount here?
And a Vixen Sphinx SXW mount.
And the mount's rated for 30 pounds.
30, yeah, 30. You can put more on it, but you get a little bit of wind. And hi.
What do these mounts run, roughly?
They're about $2,000 new, but
Okay.
I bought this used for about 12.
Oh, okay.
1200, not 12,000, 1200.
Very cool.
Here's Steve Harbath, standing near his Takahashi 6-inch refractor. This telescope gives great views, and there's always a long line of visitors waiting to take a look through it. Members from other clubs brought their telescopes as well. Here we see a large reflector telescope with a 20-inch mirror. This 8-inch home-built Dobsonian telescope was crafted in wood and has a matching wooden observing chair.
You got baffles in here?
Yeah.
So you do binocular, white light observing.
No, not white light.
This isn't white light.
Those are filters on there.
Filters.
Those are solar filters.
Okay. All right. Solar
Otherwise, I'd go blind.
Okay. And this is a parallelogram mount
Yes,
here?
sir. It is.
Oh, okay. Very cool. And did you build this parallelogram yourself?
Yes, I did. It's
Oh, very cool.
great for star parties because kids can. You always know what the kid is looking at.
Uh-huh.
Sure.
Very cool. I like it. I need to build one of these for my binoculars, but that's a project.
It's a lot cheaper than buying one. I'll tell you.
Yeah, they're expensive, aren't they?
Yeah, they're a couple $100. I bet I don't have $20. The most expensive thing on this is the stainless steel hardware.
Uh-huh.
You know, the aluminum is cheap, and most of it's built out of scrap stuff from the neighborhood.
Uh-huh.
But the stainless steel was the most expensive thing.
Uh-huh.
If it ever comes out, you're welcome to look through it here.
Okay. And these are, what power binoculars are these?
These are 10 by 70s.
You know, John, those folks looked like they really had a lot of fun at that particular event. Important thing, when is this year's event?
This year's event is going to be on September the 21st, which is a Friday night, and September the 22nd, Saturday night, from about 6 p.m. to about midnight. Longer if there's something really interesting going on in the sky, like maybe a naked eye comet or the northern lights.
Now this goes on rain or shine, right?
That's right, rain or shine, or even lightning for that matter, which happened last year.
Yes, we did have a bit of rain on Friday night.
Yes, we did.
So what do we have next?
Well, every year we have a keynote speaker which highlights the event around 9 o'clock in the evening. And this year it's going to be a returning astronaut, Drew Feustel. Andrew grew up in Lake Orion, Michigan, went to Oakland Community College, went on to Purdue University to get his bachelor's and his master's in seismology. And then he went on to Queen's University in Kingston, Ontario, Canada, to get his PhD in seismology. And what I'd like to show you is what Andrew actually does. He's a NASA astronaut. When he visited GLAC back in 2006, he was a rookie. He hadn't flown. But now he's coming back to us after having flown and on the spacewalks on the last repair mission, Service Mission 4 for the Hubble Space Telescope, and Endeavour's last trip, where they installed a new detector for the International Space Station. So let's take a look at those clips. We'll start off with his work on Space Station.
Wayne State is reaching out to the stars, or at least the star.
Thank you, Roberto, and it's a pleasure to see you all here today. Thank you for coming out and for your interest. Now, Professor DeBoer showed this picture and asked, what are we doing out here? And to be honest, I have no idea. I don't remember. This was, we like to show this image because it helps to show the scale of spacewalkers and astronauts with respect to the International Space Station. Box mentioned it's quite a large facility. In fact, it is. It's overwhelming when you're outside. And you can see how small we are with respect to the payloads that are here. This was during the first spacewalk. Myself and Greg Shamatoff were outside, and I'm retrieving an exposed facility payload that lives right up on top of this pallet. This is about the highest place you can get on the space station, and it feels like you're literally flying out there as the Earth passes by beneath you.
So as you imagine, Drew is pretty popular as speaker, and but I'd really like to show you what Drew does, at least what he has been doing since 2006. So the next clip we're going to show you is Drew doing some work spacewalking while doing at the International Space Station. This clip would be about a minute long. So let's take a look at that and see Drew at walk out at the space station.
Stands that were left over from the STS-123 mission when the boom was temporarily stored there in preparation for STS-124 when the boom couldn't fit in the shuttle's cargo bay because it was carrying up the Kibo laboratory, which is the station's largest laboratory.
Torque winch cover and the
crew's already disconnected the sensors on the end of the orbiter boom sensor system, or what was the OBSS. Those won't be used by the space station. This will just add an extra 50 feet of length to the space station's robotic arm in case that's ever needed.
Okay, go ahead.
All right. Now the second clip is the one that made probably the most news for Drew, and that is his first trip into space on board Atlantis, the space shuttle Atlantis, when he participated in servicing Mission 4, the mission to repair, for the last time, the Hubble Space Telescope. So let's take you on board Atlantis and show you Drew at work on the most amazing telescope that we've got.
And Drew, a reminder, and we'll try to remind you again, we want to make sure the MPT is on before we hand out the handle. Okay, I'll check it again. Sorry about that, John. That's all right. Does that look okay for each other still? Yep. Want to bring it down. You can just put them both around that area. Sure. Okay. And I think I can get that top one for you while I'm here if you want. Hide a bit. And now I have settings for the ASLR when you're ready. Okay, ASLR is first. We'll do that one first, and then we'll do the handle bolt. Okay.
Well, John, those were some really interesting videos. Now, besides the main speaker and the telescopes on the field, what other type of activities can people expect to take part in at Astronomy at the Beach?
Well, the Astronomy at the Beach event is a family-friendly event, so there are all kinds of kids' activity. There is a sky scavenger hunt where children are sent around the field to look at the planets, moon, the sun, and they can earn door prizes. There is a series of tables where the astronomy clubs will talk to the public about getting interested in astronomy as a hobby, maybe as a future career. Wayne State University is there, and they do demonstrations. And there's also usually a portable planetarium that gives a tour of the night sky. If the weather permits, there is a guided tour of the night sky using laser pointers held by a knowledgeable astronomer in the main steps of Maple Beach. There is also a number of talks done by local folks in the main tent. There's a fire and ice demonstration done by Kevin Daney from Delta College, and they do fire through Wayne State University Physics Department. There is also a number of vendors where people can buy meteorites or telescopes or eyepieces or books or maps about the sky.
Now, this is at Kensington Metro Park. Is there a cost to attend this event?
Right. Now, the only charge for the event is the $5 motor permit fee to get into the park. Now, if you happen to have a yearly permit, which is $20, the event is free. We don't charge tickets at the door. It's just a matter of getting your car into the park, and it's held at Maple Beach. Now, because of the construction this year, most people would get off at exit 153, which is Kent Lake Road. But that exit is under construction, so we're telling people to go to exit 151, the Kensington Road exit, and you'll drive straight into the park and follow the signs that say astronomy event until you get to Maple Beach.
Now, what are the dates of this event again, John?
Well, the dates are Friday, September 21st, and Saturday, September 22nd.
And the times?
Times again are from 6 p.m. Until about 12 a.m. The park police will extend hours if there is mitigating circumstances, if there's a naked eye comet in the sky, or if we have the northern lights.
It sounds like this is going to be another memorable event for the GLAC organization doing astronomy at the beach. I know I'm looking forward to being there again, and hopefully the weather gods will cooperate and we'll have nice clear skies to show the public.
Indeed. In most cases, it's been pretty nice. I do want to point people to the GLAC website for the event. That's www.glaac.org.
Well, thank you, John, and we look forward to seeing everyone at Kensington Metro Park.
The term of the month for August 2012 is stellar mass black hole. Now, black holes form in nature when a massive star, a star 20 times the mass of the sun or larger, explodes into a supernova, and a black hole forms from the material that's left over. Now, if the original star is between 20 and 40 times the mass of the sun, then material from the explosion that falls back in will then coalesce and form a black hole. But if the star was originally more than 40 times the mass of the sun, then during the explosion, a black hole forms directly, and other material falls in, but you already have a black hole. Now, on the Wikipedia page for stellar mass black holes, there are about a dozen candidates, and 2 of them are in the constellation Cygnus. Now, in the lower right, on the sort of diagonal line, on the lower right, there's a red square, and that's approximately where Cygnus X1 is. And the blue supergiant in the Cygnus X1 system is visible in a 10-inch telescope, and this constellation is up all night in August. The system has a blue supergiant, and it has a black hole that orbits it. And material falls off of, if you will, streams from the blue supergiant and forms an accretion disk on its way to falling into the black hole. Now, material that is closer to the black hole orbits the black hole faster than material that's further out from the black hole. And there's a friction between the stuff that's orbiting closer and the material that's orbiting even just a little bit further out. And it makes the material so hot that it releases X-rays, and that's what we detect with X-ray telescopes. Now, the mass of Cygnus X1, the black hole, is thought to be between 10 and 20 times the mass of the Sun, with some estimates at 14.6 times the mass of the Sun. This is much heavier than a neutron star, and so this has definitely got to be a black hole. Also, there are size estimates having to do with the fluctuations of energy that suggest that the object has to be smaller than about 5 kilometers. Anyway, so we have a black hole that's only about 6,000 light years away. The term of the month for August 2012 is stellar mass black hole.
Welcome back to our program. In the years that I've been doing astronomy outreach and science education programs and even planetarium shows, I've run across a number of reoccurring questions about how the sky works. How do we make sense of it all? And we're going to take about the next 10 minutes or so and try to clarify a few points to hopefully make your understanding just a little bit better. We're going to start out first with the concept of the celestial sphere. Now, until about 500 years ago, people really did believe that the Earth was the center of the universe, and this large inverted bowl rotated above us. Now, today we know, of course, that this isn't the case, the fact that we're just an average blue dot around a very average sun. But the concept of a celestial sphere is really quite helpful. And you could see in that image that we just had up, this particular idea, a large surface, if you will, that we can use to help us find special coordinates. Now, I do want to define a couple of terms that will help you with this. The first one is the term zenith. And the zenith is really just the point directly overhead. It doesn't matter where you are on the Earth. The point directly over your head is known as the zenith. Another area that you need to be aware of is the term horizon. And you can see here in this image, that gray shaded area, that would be your horizon. It's marked by the edge of the Earth. And above that horizon line is everything that we can see in the sky, and below it is really everything we can't. Now, one of the big things that people wonder about is the apparent motion of the sky. And again, back in the old days, before the 1500s, people really thought that sphere did turn over the Earth. But in fact, it really is just the rotation of our home planet. And right here you can see in the image our planet rotating counterclockwise, as seen from the North Pole, or moving west to east, as you see in the other illustration right there. Now, you'd say, well, wait a minute, Don. The sky goes from east to west, and yet you say the Earth goes from west to east. Well, to help you kind of visualize this, think of the analogy of a couple of gears. If you have two gears, you have one gear moving in one direction, the other engaged gear moves in the opposite direction. And so hopefully that will kind of clarify that just a bit more for you. Another question is, why can't we see all of the stars that they're out in the sky? And well, it gets back to the idea of the horizon and not being able to see anything below our local horizon. The Earth is our front porch to the universe, but it also is a great roadblock to seeing the other half that would typically be there. Now, the view that you do see would change with your latitude. If you were to change your latitude on Earth, we're here in southeast Michigan at 42 degrees, but if you were to change that latitude, which is the distance from the equator to the North Pole, your view of the stars would change. The drawing there in the middle, it says 45 north latitude, is about where we are roughly, and you can see the lines marking how the stars would rise, reach their highest point in the sky, and then descend back down again. However, if you were at the North Pole, which is the drawing to the right, all of the stars would neither rise nor set. They would merely go in giant circles around the sky, making great circles. Now, if you're at the equator, it would be entirely different. You would see really all of the stars rise and set. The stars would come straight up from the horizon, unlike here in southeast Michigan where they come up and then head up into the sky at a sharp angle. What this does at our latitude is it leaves some stars which are never seen, some stars which rise and set, and then there are some stars that neither rise or set at all. They're known as circumpolar stars. And we're going to go back to a previous image. You can see the line up there towards the upper left, just above the word north. Stars and constellations located in that part of the sky will never set from our perspective here at 42 degrees north latitude. Stars such as the North Star, Mizar, or some of the other stars of the Big Dipper, and those constellations that are there as well. The Big Dipper, Little Dipper, Cassiopeia, and Cepheus are known as circumpolar stars and constellations. Now, a big question that was often asked is, why different constellations during the year? When I'm giving a planetarium show during the summer and we're talking about Sagittarius, somebody will ask, well, why can't we see Orion? Well, that's because it's on the opposite side of the sky. And you can see from this diagram at the various times of the year, for part of the 24 hours, we're facing towards our sun, and for the other part, we're facing away out into space. And as the Earth rotates around the sun, its revolution, each night we look at a little bit different part of the sky. So that's why in January we'll see Orion riding high in the southern sky, and yet 6 months later, during the summer, we see Scorpius and Sagittarius gracing the southern sky close down to the horizon. Now, another issue that causes folks some question is the matter of time. We all know that there's 24 hours in a day, and we assume that the night sky works in the same way. Well, it doesn't really. Our time that we use on our clocks is based upon solar time, and that's based upon one rotation of the Earth with the sun coming back to its highest point in the sky for that particular day. There's an imaginary line that travels through the zenith that we talked about before, from the north all the way up to the zenith and then back down to the south. And that solar day is based upon the sun crossing that meridian line. You can see here in this diagram that from one day to the next, the Earth has to turn an additional 1 degree in order to get the sun to cross that meridian line once again, and that takes the 24 hours. However, the Earth's true rotation period is 23 hours and 56 minutes. That's the time it takes for a star to cross the meridian one night and to cross it again the same night. But if we're timing this with our solar-based clocks, that star will reach that point 4 minutes sooner each night. Now this time adds up, and so you have 4 minutes a day. At the end of 1 month, you've got 2 hours. And of course, we have 12 months in a year. 2 times 12 is 24. We're back to where we started once again. So actually, the true rotational period is the sidereal time, which is based upon the stars. Now, one last thing I want to cover is the seasons. What causes us to have seasons? And if you ask somebody the question, they're going to say, well, it's warmer in the summer because we're closer to the sun. Well, the short answer to that question is no, we're not. What does cause the seasons is the axial tilt of the Earth. And here in this image, you can see that the Earth's rotation is tilted 23.5 degrees to the plane of its orbit. And so the axis of the Earth is always tipped in one direction. And as the Earth circles around the sun, that pole, our North Pole, always faces in the same direction. But during the summer, it's aimed more directly towards the sun, and so we get stronger energy, which makes us warmer. Then 6 months later, as you can see on the left side of this drawing, the pole is facing away, so the northern hemisphere is tipped more away from the sun. So while the same amount of energy is reaching Earth, that energy is spread out over a larger area. Now, actually, you can see the Earth's orbit is elliptical. It isn't a true circle. So we do come closer and farther away to the sun, but we're closest to the sun on about January 3rd during the heart of winter, and we're farthest away about January or July 2nd or 3rd, which is when we have summer. So you can see the proximity to the sun has absolutely no bearing upon the cause for the seasons. I hope this short talk has helped clarify some of these concepts for you. If you'd like to look into it more, of course, you can go online and check out those resources, or even better, go to your local public library and check out a book. Also, don't forget to go to our website. You can see the site address down there at the bottom of your screen. And after this scroll of upcoming astronomy events for Southeast Michigan, we'll be back with What's Up in the Night Sky. So don't go away.
Welcome to What's Up in the Night Sky for August 2012. August will feature 2 full moons, starting with August 1st. We have a full moon. On the 9th, we have the 3rd quarter moon, and then the moon will disappear as new on the 17th. We'll have a 1st quarter moon, where you'll see half the moon in the sky on the 24th, and the full moon again on August 31st. Moving on to our planets in the western sky after sunset, you will see Saturn and Mars. This is what they look like on August the 1st. Let's move on to the 13th, where you see them both lower in the sky, but now Mars has passed Saturn up. And then on the 31st, Mars is gaining distance as it continues to rise up in the sky, and Saturn continues to sink. Now, also in the sky is Jupiter and Venus. In this image, you'll see the 2 of them hanging out in the eastern sky. We step up about 2 weeks. Well, the same night, if we move over a little bit and see Jupiter, if you look to the right, you'll see one of the asteroids of the solar system, one of the first ones discovered, asteroid Vesta. Now, the next shot we're going to show you is Venus with a beautiful crescent moon. One of the most iconic images in the sky for religion is the crescent moon and the evening star, or in this case, the morning star for Islam. We also show Venus by itself as it's higher in the sky. You can see dawn approaching in this image here at the end of the month. And we can't forget poor little Mercury. It's also visible very early in the morning, around 5 a.m., right next to the constellation of Cancer, the Crab, and the Praesepe, or the Beehive Cluster. That's what's up in the night sky for August. Please go out and enjoy the stars. They're free for everybody.